Okay, so today we're going to talk about calculating with scientific notation. One of the first things you're going to want to do is set your calculator so that's in a scientific notation mode. The reason you want to do this is because the screen might not be big enough to hold all those zeros, because if you want your answer in scientific notation but it's small enough to show on the screen, then it won't be in scientific notation mode. So just get to the point where you know how to put it in and take it out of scientific notation mode. All right, so we have 4.6 times 10 to the 23. When you're entering that in the calculator, chances are you're going to have to use a different key. You're not actually going to type in 4.6 times 10 to the 23rd. These calculators have a double E button, which I'll show you how to get to. It's a second function of a key, so I'll show you how to do that. But not all calculators have the double E button. Some of them have an EXP button. So that's another option. It's not always a second function button, but you can look at your calculator. And then even some of them even have a button that says times 10 to the x. And that's pretty easy and straightforward. So there it is. So look on your calculator, pause the video, take a look at your calculator, see if you can find one of those buttons on your calculator. Okay, a common mistake that people make is when they're typing these numbers into their calculators, they actually type in 4.6 times 10 EE23. So it's adding that extra times 10. Very common mistake. So don't do it. Your answer will end up being 10 times bigger than it's supposed to be. Okay, now let's look at what the answer is going to look like on your calculator. I've seen it in a variety of different arrangements. So 6.4 E5, 6.4 space 5, 6.4 with the little times 10, times 05, and then this last one, I don't know if I actually see this anymore. This was in older calculators. It looks like it was 6.4 to the 5th when it was the 10 to the 5th. So again, it's going to come up in a variety of different ways depending on your calculator. The thing you have to know, though, is regardless of what it looks like on the calculator, you have to write it in this format with one counting number to the left of the decimal on your paper. It has to look like this on your paper. So now we're going to try our hand at multiplication and division of scientific notation. And yes, sig figs play a role here too. But it's the same rule that you've always been using, in that you round your answer to the least number of sig figs that you have in your original equation. So let's try one. Here's a sample problem. Write this down in your notebook. So 5.6 times 10 to the 4th times 9.39 times 10 to the 5th. You want to enter that properly into your calculator. 5.6 EE4 times 9.39 double E 5. When you hit the equal sign, you get 5.2584 times 10 to the 10th. So now you have to do sig figs. Go back up to your original numbers. 5.6 has 2 sig figs. 9.39 has 3 sig figs. So how many are you going to have in your answer? Hopefully you said 2. So we come down here. 5.2, is that 5, the next 5 going to round the 2? Yes, indeed. So our answer is 5.3 times 10 to the 10th. All right, so here are some practice problems for you. I want you to put these in your composition notebooks, which means you're going to write out the problem as it is on the screen right now. You're going to solve and round to sig figs. So now you're going to try some addition and subtracting. There's a little bit of a twist to this, but the rule is the same, is that you round to the place value of the least precise first best guess. All right, so let's do a sample problem. 4.678 times 10 to the 17th plus 9.1 times 10 to the 16th. You're going to want to enter those using the proper keys on your calculator. In this case, the double E keys. And then you're going to get an answer. And you'll just write the answer out as you normally would. Okay, so you're going to identify the first best guess in your original numbers. You're going to see that the 1 is in the tenths place, which is the least precise place. So you're going to go to your answer and underline the tenths place. Does the 8 cause the 5 to round? Yes, it does to 5.6 times 10 to the 17th. There's your answer, but it's wrong. What? I did everything right. So what's the problem? The problem is you're talking about place values. And because they have different exponents, the decimal points would not actually line up like you would normally line them up, because the decimal point is where it is because of the exponent. So what you want to happen is you want all of the exponents in the equation to match the exponent that you got for the answer. Once you do that, then the place values will line up. All right, so let's see how that's done. The only one that doesn't match is the 16, so we need to change that. And we're going to change that to a 17. But you can't just change the exponent. You actually have to adjust the number as well. So you look at this and you say, okay, the exponent got bigger, so what I know that I have to do is make the number smaller. And the way that I do that is by moving the decimal point. Now, you notice that I moved the decimal point just one place. That's because the difference between 17 and 16 is 1. So I move it one place to the left because I want the number to be smaller. So there's no need to put anything back in your calculator. The calculation is already done. You're doing this just for the sig figs. So it's sort of like what we did with the number line. If the exponent gets bigger, the number needs to get smaller, and then you move the decimal. So now you can look at the numbers, identify their first best guesses, and this time your answer, you're going to round it to what we would consider the hundredths place. 5.588. Does the second 8 round the first 8? Sure does. So you get 5.59 times 10 to the 17th. And that is the correct answer. 5.59 times 10 to the 17th. So here are some practice problems for you to do in your composition notebook. Thanks for listening.